Okay, so let's find the domain of each function. On A, we just have a list of ordered pairs. And we set our domain, then for a list of ordered pairs, we're just going to list our x values. So I have what, -3, -1, 0, 2, and 4. That's my domain. B, what's wrong with this? Well, we have a fraction. So remember, to find it, we said our denominator cannot equal 0. So set up your denominator, x plus 5, set it not equal to 0, and solve, and we find x cannot equal -5. So our domain is going to be all real numbers except x cannot equal -5. Volume of a sphere, this is that real world problem. Which is my domain here? Well, my domain is going to be that radius. And what kind of numbers can I have for a radius? Well, my radius has to be greater than or equal to 0, so we just know then that our domain is our radius is greater than or equal to 0. Now, depending on where you look, some don't put the equal to, some do. I'll accept it either way. All right. And then D, what is the issue there? Well, we have a radical, and remember, you can't take this, we have an even root radical even more, and you can't take, in this case, the square root of a negative number. So I know that I'm going to need to set this greater than or equal to 0. So we end up, to get rid of the radical, let's square it. And so we really get 4 minus 3x, because the square and the square root cancel, is greater than or equal to 0 squared is 0. Because remember, technically we can't take the square root of a negative number, so the thing underneath the radical needs to be greater than or equal to 0. But by setting the whole thing greater than or equal to 0, the greater than or equal to 0, most of y'all seem to get that better. So that's why I did it. Alright, so I'm going to subtract the 4. So I got -3x, has to be greater than or equal to -4, divided by our -3. And we find x, remember your inequality changes, and we get 4 over 3. So my domain for this one is x has to be less than or equal to 4/3.